All right, welcome back to Kirsty's virtual classroom. Today we're talking about mineral uses, and we're going to go through a little bit of an activity to try to get us familiar with applying the properties we've already talked about to what they might be useful for. So we're going to go over the mineral physical properties that we talked about in the last session. So we have luster, hardness, cleavage and fracture, color, crystal form, streak, and there are many others. But remember that luster is the way that the mineral reflects light. So when you rotate the mineral in sunlight or even under a light, what it gives off, the mineral, is what the luster would be. So for instance, if it's not very shiny and it looks kind of earthy, it might be earthy or dull. If it has a very shiny reflective feature like glass would, then we would call it glassy. And then remember, we separate those between the metallics and the non-metallics. And then we move on to hardness. Hardness tells us how robust the mineral is. So we can take the mineral and see if it'll scratch a particular surface or a particular object and see what its relative hardness is to that object. So remember, that's the Mohs hardness scale from 1 to 10, 10 being the hardest mineral, which would be diamond, 1 being the softest, which would be talc. Cleavage and fracture tell us something about the way the mineral is breaking. So if the mineral breaks in a very particular routine pattern, we call that cleavage. So it's breaking along these planes of weaknesses in the actual chemical structure of the mineral. And so because it breaks along those planes, it preserves a particular shape of the crystal. If it fractures when it breaks, that means it's breaking in these irregular patterns, and there's no rhyme or reason to the way it breaks. Color is usually the first thing somebody notices about a mineral. Remember, we cannot use color for a definite identification of a mineral because it is so vast amongst the minerals. You'll see a lot of minerals with similar colors to other minerals. It's not a definitive identification feature, but it often can give an indication of what we might use the particular crystal for, or kind of tell the difference between similar crystals in the same family, but they have a slightly different chemical structure that makes them a different color. Remember, the magnesium and iron in the biotite makes it a darker, kind of a brownish black color, whereas muscovite, that's very, very similar in all the other physical properties, has a lighter color because of the aluminum in it. Crystal form is something else that that many people will recognize right off the bat, whether it has a cubic shape or maybe it looks like a little soccer ball. We saw those with the garnets. And that is how the crystal grows. Remember, this is not breaking in any fashion. Once the crystal is broken, it no longer preserves that crystal form. And then streak is the mineral in powder form. So when you streak the mineral across a porcelain plate, that's the color that you see on that porcelain plate. So let's look at what we might use some of these minerals for. So these are some of the minerals that we've looked at. We haven't looked at all of these minerals, of course, but a lot of things are used in your home that you may not even realize. So things like gypsum is used in the concrete. It's also used in your drywall. You might see things like feldspar in your glassware and some of your paper. Silica is definitely in your glass. So this would be like quartz. Is definitely in your glass. And there are many other things that you will find in your home that are made up of the minerals that we have been talking about. Okay, so we're going to go through 6 different minerals. We're going to look at their properties, and then we're going to see if you can, at the end of this video, decide which mineral belongs to which particular household item. So the first one we're looking at here is talc. Talc has a pearly to dull luster, depending on the sample. The color is white to green. This one in particular is more of a white satiny color, but sometimes they can be a little bit of a pale green. here is its chemical formula. It does have some magnesium, some silica, oxygen, and hydrogen in it. The hardness is 1, so it is softer than glass, like we discussed last time. And it's very easily pulled apart by basically your hand. And its cleavage is 1, not at 90 degrees. So it does have one particular cleavage plane. And the reason the chemical formula is on here, even though it's not technically a physical property, it's a chemical property of the mineral, is because sometimes we use the chemistry of a mineral to decide what to use it for in the real world. It's not all about the physical properties. Okay, so calcite's our next mineral. Calcite has a glassy luster, as you can see in this photograph. The color is usually clear. Sometimes they can be a little bit on the white side, but most of the time they're very clear. The chemical formula is CaCO3, so this has calcium and carbonate in it, which makes it very basic, so it does react to acid. Keep that in mind. The hardness is softer than glass. It's between a 2.5 and a 3, so a little bit harder than your fingernail. And it does have 3 planes of cleavage that are not at 90, so you see how it kind of slants a little bit. That's the not at 90 degree angle. So this not 90 degree angle right here is what we're talking about. And the 3 planes are this one, and this one. If you have trouble recognizing the planes, watch the previous video to get yourself up to speed. All right, the next one is fluorite, and fluorite has a glassy luster as well. You can see that in this photograph. The color varies very significantly. So this one happens to be purple, but it can be green, it can be kind of a tealish color, it can be a pink color. There are a lot of colors that fluorite can come in, which is one of the main minerals I like to point out as not easily identified by color. Okay, the chemical formula is calcium and fluoride. Keep that in mind. The hardness is 4. It is softer than glass, so it's not very hard. And it does have 4 planes of cleavage, not at 90. It's one of those really difficult to spot, especially in a photograph, so I won't try to point it out here. Cleavage planes. And normally in class, it would be really easy for me to show you how to put your fingers on the mineral, and we did our best this last lesson, but this particular image is really hard to see, so I'm not necessarily going to point it out here. All right, quartz is our next mineral. So here the luster is glassy. The color is clear, but it does vary. So again, this is one of those ones that might be mistaken for fluorite, but the physical properties are completely different. It does have silica and oxygen in it, and the hardness is 7, so that's what makes it significantly different from fluorite, is that its hardness is much, much greater. It is harder than glass, and there is no cleavage. So what you see in this photograph, all these points, this is all crystal form. This is the way that quartz will grow, and once it's broken, like you can sort of see at the bottom here, it does not break in this same fashion. So this is fracture, not cleavage. All right, and our next one is muscovite. So here the luster is pearly to glassy. Sometimes they do have a little bit of glassiness, and sometimes they're a little more on the pearly side. It is a brown to gray color. It has a very long chemical formula, but some of the key components are the potassium, the aluminum, and the silicon. It is very soft, or on the softer side. It's softer than glass. It has a 2 to a 2.5. And the cleavage is 1, not at 90 degrees. Okay, so this is very flat. You're looking at the flat surface here. And because there's no other cleavage plane, it can't meet at a 90 degree angle. So it's 1, not at 90. Okay, and then we have halite. So halite looks a lot like calcite. It's often confused for calcite, but there are some key differences. So the luster is the same as calcite, so it is a glassy luster. It's also clear. Chemical formula is much different. This is NaCl, which is sodium chloride. So this is basically table salt. So this is what your table salt is made out of. So halite, when you have it in hand sample, if you actually wanted to taste it, it would taste like salt. And the hardness is similar as well. It's a 2 to 2.5, so it is softer than glass. But its cleavage is particularly different. It has 3 planes, just like calcite, but they're at 90 degrees. So here's one plane, here's another, and here's another. And if you look at the interaction between those planes, it's approximately 90 degrees. So that makes it significantly different from calcite. Okay, so the activity is that we are going to look at the different properties that we just looked at, that I just presented to you, and you're going to try to match those minerals that I gave you to common household items on the next slide. You're then going to submit your answers to the Padlet I have on Canvas, and then those answers will be given to you once I have everybody's submissions, so that you'll be able to see what the actual answers are. Try not to look this up. Okay, try to do this on your own. I'm grading on submission, not 100% you got it right. I want you to try your best to do this on your own. So here are 6 different household items. So we have baby powder, we have salt, I think I have them labeled, we have toothpaste, we have Tums, we have some eyeshadow, and then we have glass. Okay, so try to match up the 6 minerals that I just showed you to one of these household items. Submit that to your Padlet on Canvas, and then we will talk about it in the next video. See you guys then.